morning, everybody. Happy Friday, last day of the week. We're just going to wait another minute or two so a couple last minute people can join in, then we'll get started. All right, good morning, everybody. Welcome to Friday's class. Hopefully you felt good about this first week of classes. So just a couple of quick things before we get started. Reminder that the chat, the link is at the top of Google Classroom, so you can open that up and you can ask questions through there. I see a couple of people that have not muted themselves, so please take the time to do that. You may have seen, I posted an announcement yesterday. It has been decided that your situational problem will be not this Wednesday, the following Wednesday. So just a quick reminder that this is a final exam and that attendance is mandatory. So it's no excuses, everyone has to be there. That's it, that's all. Okay, so Wednesday you should be here. The second Wednesday, you have to be here. Like no excuses. We will talk a bit more about this as the week goes on. Yes, I'll be giving you a list of topics that we've covered that will be on the situational problem, that could be on the situational problem in the upcoming days. So no fret about that just yet. You still have some time. Do remember that anything that you did that was on that list from CST is fair game. So analytic geometry, all of that kind of stuff is still fair game for that exam, so you need to be reviewing that at the same time. So make sure you're checking that out. You are just being graded. So I have a question in the chat already this morning, whether or not you're just being graded on the assignments or final exam. It's just the final exams. The assignments are just so you can get feedback on the types of question you could get in the final exam before you write them. But you're just being graded on the final exam, nothing else. Okay, so you have your C1, so that's not this Wednesday coming, the following Wednesday. That will be your entire C1 mark, and then you have the final exam just like you had for the CST with the 16 questions and all that, the 25th, and those will be your 2 marks that are put together to give you your final mark for this course. Okay. So that's why when I grade the assignments that you get either a 0 or a 1, meaning complete or incomplete. And if you've got a 1, you've got feedback in your question. So you just reopen the document and I've given you some feedback on where your mistakes are coming from and so on and so forth. Which brings me to the next point, assignment 2. The feedback has been uploaded as of yesterday evening. So this afternoon I'll be giving you feedback for class 3, trying to give you about 2 days to complete each of the assignments. Still noticing about half the class isn't completing them, so please take the time to do that. I do notice more people are completing the Google form than the Google Doc, which is great. At least you're completing that, but please try to keep up with that as much as possible. Okay, so we're going to start off by going over the assignment from yesterday. If you have any questions on that or from the handout from yesterday. So I have the chat open. Feel free to pop in with all the questions that you want to go over, either from the handout from yesterday's lecture or from any of the assignments. So I'm going to wait a minute and see how that feed updates and see if there are questions that you want to go over. So I see assignment 4, question 2. Okay, so we can start off with assignment 4, question 2. So in assignment 4, question 2, it says, in the figure below, the area of rectangle ABCD in square units is expressed by the trinomial squared minus 11x plus 12. So that's the area of the rectangle. So I'm just going to draw a quick rectangle here on the side. All right. This measure of its sides being binomials. Sides DA. We've also got this middle rectangle. So we've got 1 and 2 here. And we've got AB. Okay. So basically what they're saying is this is the area of a rectangle. Right here. Now normally with a rectangle you have area equals length times width. Normally with a rectangle you would have to know one of the two measures in order to be able to find either the length or the width. So you'd need the width to find the length or the length to find the width. Because there are so many different factors multiplied to give you the same number. So for 24, this could be 3 times 8. It could be 4 times 6. Or it could be 1 times 12. So we need to know which factor we're dealing with in order to be able to figure it out. But with binomials, we don't have that same relationship. Binomials, it's very specific in the way that it factors. Okay, so you can only factor a binomial into trinomial, sorry, binomial factors, and that's it. There are no other factors. So we have here a trinomial. We have the product is 24. 1, oh my goodness, 1, 4, 12, 3, 8, 4, 6, negative 11. Means is these are all negative. Gives me a sum of negative 11. So extend this down a little bit here. 2x squared minus 11x 12 gets 2x squared minus 3x minus 8 plus 12. Regroup here. So in the first two, I can pull out an x. And here I can pull out a negative 4. Minus 4, 2x minus 3. Meaning that it doesn't really matter. x minus 4 and 2x minus 3. The sides of my rectangle. Now the next thing it says is that these things are being extended by 4 and by 4. I want to know the area of the new rectangle. So I'm going to find the new sides. Be x minus 4 you can see my screen. Everyone can see my screen. If you can't see my screen, that means at the bottom you've clicked on somebody other than me. So go find me at the bottom and then you just click on my screen. But my screen is being projected, as far as I know. I can see it on the other computer. So let me know, okay? And here we've got minus 3 plus 4. 1. Now the question says, find the area, new area. We still have a rectangle. Got length times width, but we have the new length and the new width to find my area. Remember that this distributes to both terms, so I get 2x squared plus x as my new area. Squared. Questions?
Yeah, miss.
Mm-hmm.
Why did you bother with x units? So just x squared.
It's basically like saying, you know, when you find an area and then you get, let's say, 15, and then you have to do centimeters squared. That's this part. So here the centimeter squared is the unit squared. So usually for an area, you would just have to put the units, that's all. Any more problems that you want to go over, either on the assignment, on the Google Form quiz, or on the handout from yesterday? So we were fine with number 3, the factoring on the assignment, number 1 on the assignment, which was the simplifying. Any takers on that?
Can you go over number 1?
Number 1, absolutely.
Yeah.
And I see handout number 3F, so I'll get to that in a second. Okay, so this says simplify and state the restrictions for the following expression. So here what I'm going to do is I'm going to factor them each separately. I'm going to deal with on one side and the denominator on the other. These one at a time. I've got 4 terms. Look to see if I have any GCF, which I don't. There's no number that I can pull out, no x that I can pull out, which means I'm left with grouping. So here I can pull out an x squared, and I'm left with x plus 2. Here I can pull out a 4, and I'm also left with x plus 2. And then we have x squared plus 4 left here. This, we look for GCF. There's no GCF. It's not a trinomial. There aren't 4 terms, which means we look for difference of squares. Is this a difference of squares? Well, it's a difference. This is a term squared, and this is a term squared. So yes. So I take the square root of the first, which is x squared, square root of the second, which is 4, and I have 1 plus and 1 minus. Now, like I said, when you do this, always check your term to see if this one, the difference of squares. In this case, it is. We've got the first term that can be square rooted, the second term that can be square rooted. And the difference is square root of the first term, square root of the second, one's a plus and one's a minus. Now, since this is the denominator, I have to find the restrictions from those factors. So I factor 1, factor 2, and factor 3. So from factor 1, I have x squared plus 4. I set it equal to 0. And I move the 4 over, which gives me x squared equals negative 4. This is impossible. You're never going to get a number that's squared that equals negative 4. So we don't need to worry about this factor. It's not going to give us a restriction. Into the second, so I can bring this over. So x is 2, and 3x plus 2 is 0. So x can't be negative 2. So the restrictions, x cannot be negative 2 or 2. Bringing me back to my polynomial, I'm going to rewrite it in the factored version. Now, basically, I'm just looking for any factors that exist in the top and the bottom. So I've got an x squared plus 4. And I've got an x plus 2. What am I left with? 1 over x minus 2. You notice, super important too, that when I stated the restrictions, I didn't cancel and then go from here. So the restrictions are what comes from the initial polynomial on the bottom. So you actually have to state the restrictions before you cancel anything. Otherwise, your restrictions won't be accurate.
Miss, do you have to put the 1?
Do we have to put the 1
The
over?
1.
Yes. You can have, because this is on the bottom, right? So you can't, like, this is not a legitimate thing. Have a 1 up here. All right, we'll take a look at handout 3F. Talking about this one, we'll go over that in a second. Okay, so we're just going to take a quick look at that. So that's why I said if you see any multiplication, division, addition, subtraction, skip them for now, and we're going to go over them today. So this is a division. We'll take a look at this today. Okay, the other question is why negative 2? So in this problem, I'm assuming. In this problem here, we have a negative 2 because we have this as our factor. So when I put x plus 2 equal to 0, when this 2 moves over, it becomes a negative. So these two here and here, those are my numerical restrictions. Anything else before we move on? The form quiz, all of those questions were all right. Number 3 was fine on this assignment. Okay, cool. All right. So schedule today is as per usual. We've done the go over assignment quiz questions. We're going to do the new material now. And if we have time, go over some questions at the end. So yesterday we started talking about rational expressions. So we talked about the fact that they're basically fractions with polynomials. And we talked about, basically we're going to be doing all the same things with those as we do with fractions. But there was this added bonus, or this added issue that we had with rational expressions that we didn't have with fractions, which were the restrictions, because we can't have a denominator equal to 0. Therefore, we have to account for that. So we found out how to solve the restrictions, as we did here in this example. And then we simplified, which is something we did do with fractions. So when you simplify, basically you're taking out any common factors that exist in the numerator and any common factors that exist in the denominator to reduce it to the simplest rational expression that we can have. So just like with fractions, we want the simplest expression that we can have. The next thing you learn to do with fractions is multiplication. So that is the next thing that we are going to do also with rational expressions. So the notes are there. I'll give you a minute to copy the blue in, and then we'll get started. Okay, so we'll get started. So the first steps are always the same. Like I said with rational expressions, you don't do anything until you've factored, because everything that you're going to be doing from the beginning always starts with factoring. You need to know the factors to be able to do any of it. State the restrictions, anything after that. So you start off by factoring the numerator and denominator of everything. So we're going to be multiplying rational expressions, which means we have one times another, which means you're going to have at least 2 numerators to factor and at least 2 denominators to factor. From there, you're going to state the restrictions. The restrictions come from all the denominators. What you're going to do is then you're going to cancel out any factors that exist in both the numerator or denominator and denominator. A fraction. But we're not restricted to each of the different rational expressions in order to be able to reduce. If I have a factor in the top of one and the bottom of the other, they still cancel out. So I need one factor in the top, one factor in the bottom in order for it to cancel, and then we're good to go. What we're left with, that's when we perform the multiplication. Are we ready? Cool. Okay, so we're going to do a few examples of this. So we're going to multiply the following rational expressions. So step 1 says factor. This is going to be the longest step because all of a sudden you have 4 different things to factor. So we have 1, 2, 3, and 4. Okay. So I'll start with 1, 15x cubed plus 5x squared. And remember when I said that if you weren't 100% on factoring, you get a lot of practice? Well, this is a lot of practice. Here it's binomial, the GCF. See if there's a GCF. There is, so I take it out. GCF 5x squared, I'm left with 3x plus 1. So that's factored. Number 2, x is factored, so I just leave it alone. Number 3, is a trinomial. I always look for a GCF. There's no GCF. Trinomial means I'm going to product sum it. So the product is -6, and my sum is -5. Not -1. I have 1, 6, 2, and 3. Since my sum is negative and my product is negative, that means that these are going to be negative. Which one gives me -5? This one. I have 3x squared minus 5x minus 2 splits into 3x squared minus 6x plus x minus 2. Regrouping 3x, x minus 2 plus 1, x minus 2. Which gives me, when I reposition this, x minus 2, 3x plus 1. I'll leave it there for a second before I go up. Okay. All right. Number 4. So what I'm looking at from number 4 is that there's no GCF. It's a trinomial, so I could product sum it. But what do I notice about this one? Well, I notice that here I have 9x squared, and here I have a 1, which is a square term as well. So I'm wondering if I have a perfect square. So let's check it out. So I have 3x, 1. This would be a plus. I check. 3x times 1 is 3x, times 2 is 6x. That's good to go. If you didn't see this, that's okay. Product sum works as well. So this is a side note. I would have a product of +9 and a sum of 6. So here I have 1, 9, 3, 3. Obviously, we've got the 3 going on. Okay? If that happens, I'll answer your question in a second. Just let me finish this. 9x squared, this splits into plus 3x plus 3x plus 1. Regroup here and here. You can put a 3x, and you're left with 3x plus 1. And here you can pull out a 1, and you're left with 3x plus 1. Regrouping gives you 3x plus 1, 3x plus 1, and that is the same thing as saying this is 3x plus 1 squared. So when in doubt, if you're not sure, you can still product sum a perfect square. And you'll get to the answer. It creates a lot more work from you. Either you do one step or you do the whole product summing process. But when in doubt, use that. How do you tell if it's a perfect square? Good question. So the issue is if you have to think about it. So you may not see it, but you should be looking out for it. To have a perfect square, this first term has to be the perfect square of something. So you're looking for the numbers like 4, 9, 16, 25, those type of coefficients. 1 is a perfect square number. The third term has to be a perfect square number. If that's the case, you may have a perfect square. So you test it out. You say, well, I take the square root of the first, the square root of the last to create my perfect square, and then I test to see if the middle term works. So if this is a perfect square, if we remember, it should be this term times this term times 2. So I check it. 3x times 1 is 3x, times 2 is 6x, which we have, so this is good to go. You may miss it. The reality of the situation is you may not always catch it. Okay, you may not see, oh, perfect square, not perfect square. That's the good thing about this is when in doubt, work anyway. So if you miss it, it's fine. It just saves you some time if you get used to looking for it. We're going to state the restrictions. We're going to do this for a couple, and then we're going to stop stating restrictions. So the restrictions come from denominators, which means from term 2 and term 4. So from term 2, if I set 15x equal to 0, divide by 15, x is 0. So that's restriction number 1. Number 2, because this is a square, it's just the same thing, so I don't have to do it twice. 3x plus 1 equals 0. So 3x is negative 1 if we bring the 1 over. So my restriction is x is negative 1. So the restrictions for this problem over 3 are 0, and negative 1 over 3. Now I go back to my initial problem. Everything's factored, which means that I actually want to complete the problem now. So I'm going to put everything here in its factored form. So I got the 5x squared, 3x plus 1, over 15x times x minus 2, 3x plus 1. Sometimes it's easier to see, instead of writing it as squared, write it as this. Expand it. So now essentially you're looking for any factors that exist in a numerator and a denominator. So here I have this 3x plus 1, which is in a numerator. This 3x plus 1 is in a denominator. So they cancel out. This 3x plus 1 is in a numerator. This 3x plus 1 is in a denominator. So they cancel out. Here I've got x squared and x. So this is 2, and I'm left with only 1x. Finally, the 5 turns into a 1, and the 15 turns into a 3, because I'm reducing it by 5. All you do now is rewrite whatever you're left with. So on the top, I'm left with an x, and I'm left with n times x minus 2. On the bottom, I'm just left with a 3. So this is my solution. You do not want to try to multiply this back in. Because when you want the simplified version, you want it broken into its factors. So you do not want to be putting it together. So this is a perfect final answer. Okay? Any questions on that?
So, Miss,
Mm-hmm.
with the 5x squared and the 15x, you just, I know you reduced it by 5, but you also canceled the x's on both. So that's how 5x squared just became x, and the 15x just disappeared.
Exactly. X2 and X1, this just becomes X1 on the top. And the 5 and the 15, if I divide them both by 5, that's what I'm left with. But then we know that we don't have to write this one. Okay?
All right.
All right. So these problems are quite long. Absolutely. So I'm going to let you try number 2 on your own. You have all the tools. So factor, restrictions, cancel, put together. So I'm going to give you 3 or 4 minutes to try this on your own, and then we'll take a look at it together. Do we need another minute? Okay. So we have 4 different terms. We're going to factor all of them. I've got a 1 and a 2 and a 3 and a 4. So 1, x plus 6. I can take out a 3 and we're factored. The trinomial, it's not a perfect square. There's no GCF, so I need to product sum it. Product is negative 12, 1, 12, 2, 6, 3, 4. Sum is negative 4, meaning that these are negative. So this is how it breaks up. So we've got x squared minus 4x minus 12. This splits into 6 plus 2. Okay. Pull out an x from the first and a 2 from the second. Reworking this. Perfect. 2 is one of the things that will give me a restriction. So while I'm here, 1 and factor 2. 1, x minus 6 is 0. So x is 6. And here, x plus 2 is 0 from 2. So x is negative 2. 3. We have x squared minus 36. There's no GCF, so I'm going to see if this is a perfect square, not a perfect square, excuse me, a difference of squares. It is, so I square root the first and the second, 1 plus 1 minus. Just briefly, I got a question that said, x plus 6, x minus 2. No, they should be reversed. Like the sign should be reversed. Then we have number 4, 2x plus 6, where I could pull out this gives me a restriction. So this 2 I don't care about. The x plus 3 does. So that is what I can solve for my restrictions. In this problem, x can't be negative 3 from that factor, x can't be negative 2, and x cannot be 6. On the side here, we're going to rewrite everything factored out. Now we're looking for factors that exist in both. So here I have an x plus 2 in both the top and the bottom. And then I have an x minus 6 in both the top and the bottom. Factors that I can cancel. So I rewrite what I'm left with on the top. So I'm left with a 3 and x plus 6. And I'm left with a 2, x plus 3. Any questions? Sure, if you want to do another one by yourself, we'll take a look at number 3. I'll give you 2 or 3 minutes to look at that. Take a look at number 3. Okay? So 2 or 3 minutes, and then we have to move on. Yes, I can. So we'll give you another minute. Okay, we'll start to take a look at this together. So we have the multiplication. We have 1, 2, 3, and 4 different factors. (2x plus 3), there's nothing to pull out of there, so it is factored. X minus 1, same deal. Makes our lives easier. This, for number 2, does give us a restriction. Bring the 1 over. X is 1 is going to be one of my restrictions. Factor number 3. We have a trinomial. It's not a perfect square. No GCF. The product sum. So my product is -3. 3 only has 2 factors. My sum is 2, so it's going to be -1 and 3. So minus x plus 3x minus 3 is what it splits into. If I regroup here and I regroup here, here I can pull out an x, leaving me with x minus 1. Here I can pull out a 3, leaving me with x minus 1 as well. This and this regroup to give me x minus 1, x plus 3. There are no restrictions coming from a numerator. 4. 4 is not a perfect square. There's no GCF, so I'm product summing. Product is -12, is -1, 1, 12, 2, 6, 3, 4. Negative sum means these are negative. Sum of -1 is these 2. So I get 2x squared minus 4x plus 3x minus 6. Here I can pull out a 2x, leaving me with x minus 2. And here I could pull out a 3, leaving me with x minus 2 as well. Regroup x minus 2, and here x plus 3. These two do give me restrictions. So 1 equals 0, so x is 2. Here, 2x plus 3 equals 0. Move the 3 over, it becomes negative. And I divide by 2 to give me x is -3 over 2. Our x cannot be -3 over 2, and it can't be 2. I'm going to rewrite this. I have 2x plus 3 over x minus 1 times. This is what I have on the top of the second. This is what I have on the bottom. All I'm looking for now are factors that cancel. So I have a 2x plus 3 here and a 2x plus 3 here, and an x minus 1 here and an x minus 1 here. What this leaves me with on the top is x plus 3, and on the bottom, x minus 2. You cannot cancel the x. I remember these are factors that have brackets. Either you cancel the whole thing or nothing. So, just to give you like a numerical example, if I have 6 over 10, we know this to be 3 over 5. What's happening is we're saying 6 is 2 times 3, and 10 is 2 times 5. And because they're multiplying, I can cancel these out. If we were to do what you're suggesting here, which is multiplication, it's an addition. What we would do here, we could say, well, this is the same as 3 plus 3 and 3 plus 7. Cancel it out and get 3 over 7. That's not the same as 3 over 5. So this doesn't work. It's not a thing. So you can't cancel individual factors when you have a plus or a minus. The answer. There's nothing more that you can do. Okay? All right. Multiplication. Now we got division. Give you a minute to copy this down. Okay. All right, so in order to divide rational expressions, you are going to factor the numerator and denominator of all terms completely. But this time you're going to state some extra restrictions. So we're going to do this once and then we're going to start forgetting about restrictions because I think we understand what we have to do. So we are going to factor the numerator and denominator all completely. We are going to state the restrictions for the denominator of the first term and the top and the bottom of the second. Because we know when we're dividing fractions, we flip the second fraction and then multiply, which means that in the original expression, the bottom is the bottom, but then when we flip it, the top becomes a bottom as well and could give us a problem. After you flip and change the division into a multiplication, you cancel anything you've got doubles of, and then you finish up. So let's take a look at what this looks like. All right, so here we have factor 1, factor 3, and factor 4. So again, we are factoring everything. So not a perfect square, no GCF, product, sum. 1 and 2, and the 2 is going to be negative, so that I have a sum of -1 plus x minus x minus 2. Grouping gives me x plus 1. Here I can pull out a -2, x plus 1, regroup. Number 2, x squared minus x minus 6. The same situation. So here I have a product of -6 and -1. So I have 1, 6, 2, and 3. Sum of -1 is going to come from here. So I have x squared minus x plus x minus 6. Okay, so I want to just ask me to go back quickly. So we'll take a quick pause on this. Miss the blue of step 4. Okay. And then here we continue, we regroup. X minus 3 plus 2, x minus 3. And we rearrange. We also have factor 3, which is x plus 1, and factor 4, x plus 2. But both of those are already factored. Okay? Now, my restrictions come from this one and this one and this one for division only. So that means that I have 1, 2, 3, and 4 restrictions. So 1 plus 2 is 0. So x is -2. From 2, x minus 3 is 0. X is from 3, x plus 1 is 0. So x is -1. And from 4, x plus 2 is 0. X is -2. So my restrictions are that x cannot equal -2, -1, -2 is already there, so I don't have to rewrite it. Now what I have is x minus 2 plus 1 over x plus 2, x minus 3 divided by x plus 1, x minus 2, x plus 2. Sorry. So next step says I'm going to flip this one and change this to a multiplication, just like we would do with fractions. So I rewrite the first. Times x plus 2 over x plus 1. Now I cancel anything that's on the top and the bottom of any fraction. So I've got an x plus 2 and an x plus 2. I've got an x plus 1 and an x plus 1. Nothing else can cancel. So here I'm left with x minus 2 over x minus 3. And I'm done.
Miss, what's the whole point of finding the restrictions?
So the point of finding the restrictions is that you cannot divide by 0. So if you plug in any of these x values, any of those numbers for x in this equation, you're going to get divide by 0, and you can't have that. So you just have to account for it. But lucky for you, if this isn't a 10-point problem, you absolutely have to do this. Okay, you have to make sure you state the restrictions. However, if this is in an A or a B, we saw that sentence yesterday, given that the denominator is equal to 0, is not equal to 0. If you see that sentence, you don't have to do the restriction step because they're saying, we've done it for you. So you hope to see that sentence.
Okay, thank you.
You're welcome. Then what would you do? If you see that sentence, basically you would do the problem exactly the same as what you did. Eliminate all the red steps. For instance, if you get this as a question on your final, given the denominators are not equal to 0, solve the following. We'll do one that would look like that. See what the difference is. Yeah, you just do the same thing without the restrictions. We're going to take a look at this problem anyway. So we've got factor 1, 2, 3, and 4. So factor 1, 3x squared plus x minus 3. This is a trinomial. I need to product sum. Product is -9. Sum is 8. So I have 1, 9, 3, 3. Sum is positive, meaning the smaller numbers are negative. So that's what you get. So this breaks into 3x squared plus 9x minus x minus 3. Regrouping here gives me 3x plus 3 minus 1, x plus 3. Regrouping 3, 3x minus 1. Reduce. I'm going to, oh no, we can't. It's not too bad. Product is -6, is 1. 1, 6, 2, 3. We've got a positive sum, which means the smaller numbers negative. Here we go. X squared minus 2x plus 3x minus 6. We regroup here, pull out the x. Here you can pull out a 3 and rearrange. Factor 3 is factored, and factor 4 is factored as well. So because it says that given the denominator is not equal to 0, yada, 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 you don't have to do the restriction step. So all you have to do now is say, well, plus 3x minus 1, minus 2, divided by 2x plus 1 over x minus 2. added step in the division is dealing with this. It becomes a multiply, and these two flip. Yes, you're allowed a memory for the situational. X minus 2 is there. X plus 3 is there. So what are we left with? 3x minus 1 over 2x plus 1.
Miss?
Yep.
Could this be used in a situational problem?
Potentially. I don't know every situation in which they would use it, but
Because what would they usually have as a situation? Like what subject? Like would they have rational expressions or factoring or?
I can't really tell you because every situational problem is so different. But all I can say is everything's fair game. Okay.
Yeah, and so long as it says if the denominator is equal to 0, then we don't have to restrict anything.
Exactly. So
All right,
usually
that's all.
if you would get this in a part A or part B, they would put that statement in there. So that way you don't have to worry about it. All right, so last thing that we're going to do with rational expressions, very exciting, is adding, subtracting. So I'll give you a minute to write this down. Sure. Okay, so the last thing you do with fractions is add and subtract. So the same steps that you follow for fractions, you're going to follow for rational expressions, except for the factoring and stating the restrictions. So for number fractions, you would find the lowest common denominator, put them on the same denominator, and then just add the numerators. So notice that's step 3, 4, and 5. We just have 1 and 2 extra because it's a rational expression. So let's take a look at what this looks like. We ready? right. So, not like full screen mode. Okay. So, step 1 says factor. 1, 2, 3, and 4. 1 is factored. 2 is a difference of squares. So we've got the x that's square rooted, the 1 that's square rooted, 1's a plus, and 1's a minus. 3 is factored. And 4 is also factored. This is the kind of problem you dream of. Only one factoring to do. So then I rewrite it. We're going to go on the idea from here on out, just because we've gotten a lot of restriction practice, that the problems say given that the denominator is not equal to 0, okay? Because we don't have a lot of time left.
But for addition and subtraction, do we have to write them only for the denominator this time?
Okay, so we'll do one with the restriction. So the restriction would come from here, and it would come from here. So 1, 2, and 3. So from 1, you would have x plus 1 equals 0. So x is negative 1. For 2, you would have x minus 1 equals 0. So x is positive 1. And from 3, x minus 1 equals 0. So x is 1. Your restrictions be x cannot be negative 1, 1, and 1's already there, so that's fine. So let's rewrite our fraction. We have x minus y, x plus 1, x minus 1, plus y minus 1 over x minus 1. So what you're going to do is you're going to look at the denominators and you're going to compare. See, they both have this x minus 1 term. The missing is I have this and I don't have it here. What I'm going to do is I'm just going to multiply this expression by x plus 1 on the top and x plus 1 on the bottom. Because my common denominator, my lowest common denominator in this case, is just going to be whatever factors I see. Theoretically, I could double up on this, but because it's the same, I don't want to put another one. I'm just going to rewrite this all together. Now, the bottom is the same for both fractions. Can I go over it again? Sure. We'll do a couple like this. So you're looking for the common denominator, so you're looking at the factors. So you've got this as a factor, the x minus 1, in both. Perfect. But you have an x plus 1 here. You don't have here. So you're going to add it on, multiplying the top by that factor and the bottom by that factor. So it's just like if you have 1 plus 2 plus 3 over 6. To get this to 6, would multiply this by 3 and over 3. Give me 3 over 6 plus 3 over 6. So this is the step you're doing. You need to get this to the same denominator, so you're going to multiply the top and bottom by something that's the same. That's what you're doing here. Once the denominators are the same, all you have to do is add this together, the tops, over x minus 1, the denominator. Do not add the denominators. You recopy the denominators and you add the numerators. And you're done. In theory, you can do this binomial FOIL, which is really annoying. xy plus y minus x minus 1 and then reduce. So this x is going to cancel with this. This y is going to cancel with this. Don't you add the y and the x? No, you can't add x and y. They're two different terms. You can only add like terms. Where? Here? Here? So when we multiplied this out, we did. We FOILed to get these terms here from here, and then we just added our like terms together. Negative y and y goes away. It's like adding something and taking the same thing away. You're left with nothing. And you have x minus x, same deal. You're adding something, taking it away, so they cancel out. So technically we are adding, it just so happened that they canceled out, unfortunately.
Miss, do you have to do this step, or you can just leave it like that?
And this one wasn't too tricky to do. If it's really complicated, leave it. If it's not, do it. On the final exam, I would recommend to do it just because, especially if it's in a part B, like if you're lucky, a part B question would more likely be a multiplication or division. But if you're unlucky and it happens to be an addition subtraction, reduce it as much as possible. Put everything together that you can. Never touch the denominator after. Play around with this because they give us a very small window of answers that can be accepted. But hopefully you'd only get a multiplication or a division. So let's take a look at another one. So in this case, this is like case scenario, it's factored. So you see 1, 2, 3, and 4. There's nothing there. Okay. So basically, what you're doing is you're comparing the denominators, okay? So I look at this denominator and I say I have an x plus 3. Do I have that in the other one? No. So I need to add it. There's nothing else for me to do here. Look at this denominator and I say I have x minus 3, x x plus 3. Do I have both of those in the other? No. I'm missing the x minus 3. So I add it in. I'm going to multiply this out. So that's a perfect square, so we can use our perfect square relationship. Same thing here. I compare. This denominator is the same as this denominator. So I just take these terms and I add them up, not touching the denominator. I just recopy it. Now I see here what I can put together. So I have an x squared and an x squared. That gives me 2x squared. I have minus 6x plus 6x, so they go away. And I have 9 and 9, which gives me 18 over x plus 3, x minus 3. You can also just factor out this 2 here. Just in case it were to cancel out.
Why did the x squared become just x when you factored out the 2?
No, it wasn't supposed to.
Okay.
There we go.
Thank you.
You're welcome. Thank you. Okay, let's do one more quickly before we look at the last thing that we have to look at today. Okay. Just for the sake of time saving, after this very quickly, okay? So we know how to factor now. So just know that you have to factor. Because right now we're working on this. We're working on the adding part of this. So what we look for is I look at the denominators. So here I have an x plus 1 and an x plus 1. That's good. I have a second x plus 1. I don't have here. So I need to add it. So now these two are present in this one. Now I compare here. The x plus 1 is good to go. The x plus 1 is good to go, but this x plus 3 is not. So I don't have the x plus 3 here, so I'm going to add it.
Wait, why did you put x plus 1 in the denominator? It's supposed to be x plus 2.
Ooh, good catch. All right, so now I just rewrite this. Now we look and we have identical denominators. So all I do is I add the tops and just recopy the denominator. In this case, it's a little bit funky. That's okay. I have this something minus the identical something. So if I have 2 minus 2, what do I get? 0. So actually, this turns into 0 over x plus 3, x plus 1. X plus 1 is just 0. We wouldn't have expected that these two, just by looking at them, would subtract to give me 0. But when I actually do the addition subtraction, I do get 0. All good? Okay. So we have one last thing to talk about very, very quickly. But we've already kind of done it. So that's why we're going to blitz through it a little bit quicker. No, not what I wanted to do. That's okay. So now we're going to be solving second-degree equations. Okay. So basically we are going to be solving quadratic equations, so second-degree equations. And here is the method. So we're using this idea that if I have two things that multiply to give me 0, the only thing that gives me 0 is multiplying something by 0. So if A times B gives me 0, then either A is 0 or B is 0. Because you can never, you're not going to find two numbers that when they multiply together give you 0 if one of them is not 0. So we're going to be using this idea to solve quadratic equations. So we're going to set one side equal to 0. We're going to factor And then we're going to set each factor equal to 0 separately, and those are our solutions. Okay? So let's just take a look at this. So in this case, sure. Okay, so in this case, you have this quadratic equation. You follow the steps. You want to solve for x. So step 1 says set one side equal to 0. That's been done for you. You want to factor this now. So this is a product sum. So my product is negative 15. My sum is 2. Meaning these ones are negative, so I've got these here. Regroup, put an x from the first, leaving me with x minus 3. 5 from the first, the second, leaving me with x minus 3. Rearrange. Now, all we do is say, well, we've got these two things that multiply to give me 0. Either this one has to be 0, or this one has to be 0. Kind of what we were doing with restrictions. We were factoring and then setting all the factors equal to 0. It's the exact same thing. So if I move this 3 over, x is 3. Move this 5 over, x is negative 5. That's it. So we were doing this with rational expressions without actually saying, look, we were doing this with rational expressions. For 2, one side is already equal to 0. Oh, wait. So factor this here. Oh, no. Lovely. Here, you have to factor. So I can pull out an x. I don't know if it's 2x plus 5. And this is factored. So this is equal to 0. Sorry, froze. Had to reset it. So from here, either x is 0 or 2x plus 5 equals 0. So I solve. I move this over and divide by 2. So my solution is -5/2.
So, Miss,
Yep.
whereas restrictions, we're writing x does not equal. Solutions is x does equal.
Exactly. All right. Number 3, one side is not 0, so I have to manipulate the equation to set one side equal to 0. First thing I'm going to do is I'm going to multiply this, open up that bracket. So that gives me 4x squared minus 12x equals -9. And then I set one side equal to 0. 4x squared minus 12x plus 9 equals 0. Now I'm going to factor. Is this a perfect square? Yup. Square root of this is 2x. Square root of this is 3. Minus means minus, and we check it out. 2 times 3 is 6x, times 2 is 12x. So we actually have two factors, but they're doubled up. So I just say 2x minus 3 equals 0. I move the 3 over. And then I can divide by 2. So my solution is 3/2, and in this case, I only have one solution. Okay. So we're going to stop here. We'll save the word problems for Monday. There aren't that many on your assignment anyway, but I'll check it out if there are. You have until Tuesday to finish this assignment anyway, so you could just wait. The answer for 2 was -5/2 and 0. So basically, the handout's going to be released in 5 minutes. You can work on that. Same thing with the assignment, Google Form, Google Doc. I'm going to look at them on Tuesday, so take a look at those over the weekend. The handout for today is just a whole bunch of rational expressions with some of these solving equations. So do as many of these as possible. Practice does make perfect, so make sure you're paying attention for that. On Monday, we'll talk a bit more about the situational problem and go from there. As per usual, if there are any questions, feel free to send me an email. Feel free to also rewatch the video on YouTube. The link is in the Google Classroom. You just have to scroll down to find it. Other than that, I'll let you go. Have a great weekend. The weather's kind of not very nice today, so it might be a perfect day to do some math. Whatever.
Thank you.
But have a great afternoon and a great week.
Thank you.
Thanks, Miss.
Thank you.
Bye.